Hi, I'm Daniel Kashabi, and this is a short video presentation on our MNLP paper titled GooAQ, Open Domain Question Answering with Diverse Answer Types. This is a joint work with collaborators from Allen and Institute for AI, University of Washington, and University of Pennsylvania. Consider a setup where a natural language question is given to a language model, and the model it has to use its internal or external knowledge to provide an answer for this question. There has been a lot of work on the setup. Here are several notable works that have published data sets for the setup. The limitation for most of these works is that they often focus on niche answer types, mainly on short responses and in a few cases on long responses. The challenge is that in contrast to the focus of prior work, many of the everyday questions that humans deal with and pose to search engines, they require a more diverse set of response types. These can be questions that require multi-sentence descriptions or a snippet response, or questions that ask for a collection of items such as ingredients or steps towards achieving a particular goal. These are typically how-to questions. Even when the answer to a question is short, it can be of a rich set of types. It could be about unit conversion, it could be time zone conversion, or it could be a variety of knowledge lookup questions. Such diversity of answer types is something that is not well represented and well understood in the existing literature, and that's exactly where our contribution comes along. Motivated by this, we introduced GooAQ, which contains questions with a variety of answer types within a unified dataset and collected using the same coherent process. GooAQ contains 3 million questions with a snippet or collection answers or a variety of short answer types. Let me give you a brief description of how we collected GooAQ. GooAQ questions are collected automatically from Google's autocomplete feature. We start with a seed set of question terms such as who, where, and so on. We bootstrap based on this set by repeatedly querying prefixes of previously extracted questions in order to discover longer and richer set of questions. After extracting Google questions, we extract their answers from Google search results. Our extracted questions, because of their popularity, often trigger answer boxes in the search result containing the response deemed best by Google, which we extract as the answers to our questions. Subsequently, we conducted a human evaluation on our collected data where our annotators deemed them to be of high quality. Now, how do we use GooAQ? Obviously, we can use GooAQ as a resource in a variety of ways. In our case, we use it to better understand different answer types. GooAQ, by virtue of supporting various types of answers, it enables a quantitative study of inherent differences among answer types. In particular, we are interested in understanding whether different answer types benefit similarly from pre-training, from labeled data, or from larger models. To understand these questions, we conduct a series of controlled experiments that I'm not going to get into their details here, but you can find their details in the paper. Now, let me summarize what we found. Here are our findings. On the question of whether different answer types benefit similarly from pre-training, or while pre-training has little benefit for short response questions, it turned out to be key for generating a snippet and collection responses. We hypothesized this is because response fluency and coherence are more important for long answer generation. Regarding the value of labeled data, we observed the opposite. Short response questions benefit consistently from increased amounts of supervised labeled data, whereas both snippet and collection response questions show minimal gain when given several orders of magnitude more training examples. Lastly, on the benefit of model size, we find that larger models tend to be more effective in all cases as expected, but they show more gains for snippet and collection response questions compared to short response questions. Such discrepancies in behavior of different answer types with respect to parameters of model design is something that's new. It hasn't been studied as much in the field, And we hope that our current findings is going to motivate more follow-up work in this direction. In summary, we presented GooAQ, a collection of 3 million question and answer pairs with a diverse set of answers. We have done crowdsourcing assessment of this dataset to show its quality. We benchmarked state-of-the-art models on GooAQ, both in terms of their automatic and human evaluation, and observed remarkable difference in how these models behave on different answer types. Lastly, we find that GooAQ is a valuable resource for training models. For example, in the paper, show its value for training models for Eli5 and other long answer benchmark. GooAQ is public. Give it a look. Let us know what you find out. Thank you for your time.